Hello, today we're taking a look at scanning a wheel with a R3 scanning system and a rotary table, and how we can use this to reverse engineer the shape of this wheel itself. As you can see, we're using a structured light scanning system, which is capturing an image on the part, then rotating it around and repeating this until we go all the way around the part. This can be fully adjustable from just 4 scans all the way up to upwards of 60 scans. Right now we're doing 24 to get a decent amount of data on the part. We don't have to do this many, but it is helpful to get more information rather than less. The scanning system scans at approximately 1.5 seconds per scan, which allows us to quickly gather quite a bit of information. So it's not taking us a whole lot of time to go around this part and gather all the data that we need. Okay, once we have gone around the entire wheel, you can see that we've captured all the data from the middle portion. We did not gather the top area or the bottom area of the scan. The main reason being that we do not need this information to fully reverse engineer this part. All we really need is the profile of the wheel, which we can then use to reverse engineer the shape. So once we have gone ahead and gathered our scan data, you'll notice that we don't have the top information and the bottom information of the scan. And the reason behind that is because we don't necessarily need it to create this wheel. All we need is this curvature information, which we can see right in this area. So what we'll use is space claim to come in and help us recreate this wheel. So we have our center line and our surface, and what we're going to do is we're going to revolve the surface around the center axis You can take this falling around out, Alex. Alright, so we'll revolve this surface around the center axis, and in doing so, we create the shape of our wheel. So as you can see, this is a very quick and efficient way of coming in and taking our information on our wheel, scanning it, and then bringing it into space claim to quickly revolve out the information that we need to understand. So from here, now that we have gone ahead and revolved this outside profile of the wheel, we can move on to the internal cutouts and other geometry. So we can simply select the information that we want based off of the STL mesh, and we can just take one of these profiles, then come over to our solid model and simply revolve the surface around the center axis, and then we have our values, which we can come in and create. So once we have these surfaces, we can extrude them out as cuts, and we can do the same thing for the bolt hole locations. So we can either create these from a 2D sketch, or we can create them from the actual geometry of the wheel. This makes a very quick and easy solution for reverse engineering wheels with a R3 scanner and space claim. If you have any further questions, feel free to contact us at gomeasure3d.com. or by phone at 434-946-9125. Thank you and have a great day.